Hi everyone, Kush this side. Welcome back to my channel, DevOps Cloud Easy Learning. This is session number 4 in our Docker 101. And if y'all have not gone through the earlier video tutorial uploads, please go back and check them out. In our session number 3, in our session number 3, we had done a literal walkthrough of different Docker CLIs. That was a cheat sheet tutorial kind of a connect. What we're going to do today is we will go through Docker volumes. All right. See, we know how Docker now works. Why do we need Docker? What's an image? What's a container? How do we interact Docker client with Docker daemon? As part of our demo all throughout, what we have seen is if at all we remove the container, things are kind of lost, right? Because we are working as an isolated unit every time within Docker. So everything is bundled together in one compact unit, which is a lift and shift setup. So if you've created something, it is created with all its dependencies bundled together. So if that something is removed, everything is also removed. Now imagine a situation wherein I am wanting to run an application wherein I want to persist something, irrespective of the situation or scenario where my container may be deleted for whatever reason. All right. So in this case, what I need something which is having an existence outside of the container world. Make sense? So that if the container is gone for whatever genuine justified reason, this asset is available wherein I'm wanting my persistence to kind of stay, right? And that's what is available by virtue of Docker volume. So Docker volume is an independent entity within Docker. We create Docker volume again using Docker CLIs, and it exists independent of the Docker container setup. What we do is we bind the Docker volume, whatever we have created, to the container based on the requirements. If my container is wanting to persist data and it doesn't want that information to be lost when the container is removed, we use Docker volumes. All right. I hope that understanding is clear with you all. If you all have any further questions on why we need Docker volume, please post in the comments and I will try to answer them. All right. With that being said, we will get started. All right. So again, this repo is shared. This is one repo that I'm using for all our tutorials. It is available under the YouTube upload video description. Please go ahead and check it out. It's a public repository available in my DevOps Cloud GitHub page. As usual, if you all have any questions, put it on the comments. Okay. So what are we going to do? We will do demo with volume. We will go through all different scenarios that we can encounter when we are wanting to work with volume. Why do we need volume? By literally running and seeing things happen. So we'll keep it very less theoretical and we will keep it very heavy on the demo because these are simple commands, and once you see the output it becomes much clearer, right? So first thing first, what we will do is we will see what happens when there's no volume and my container indeed wanted to persist some data. All right, so what I'm going to do, we are going to run a container in detached mode. Remember, IT interactive terminal and -d is detached. So I do not want anything to attach to my terminal. I want the container to do something and exit. All right, so right now, let's see what do I have running. So ps-a will give me, okay, my Docker is not running. Let me start the Docker. So I'm starting the Docker engine. There you go. Now when I say Docker ps-a, so right now I do have one container which is in exited state. So I'm going to remove it because we want to start with a clean slate, right? So I have removed this, and now when I see, I don't have anything currently running as a container in my Docker setup. So what we will do, we will start a container in detached mode. It is a simple Alpine container that we are starting. Let's run this command, okay? So we have this command and I'm going to run them. I'm doing a Docker run -d detached mode --name. I want the name of the container to be volatile test. The image is Alpine, and then I'm passing it the command which I want to override or provide, which is tail -f dev null. Okay. Now I run this, I get back the alphanumeric ID. And now if I see, I have a running container. You see the status is up 4 seconds ago. So I have now, just now, created a container which is running. Now, what I want to do is I want to create a file in this running container. It's called ephemeral data.txt. Now, because I'm using command, remember the command entry point demo which we did, I think that was session number 2. Go ahead and check that out. Because I'm using command, I can always override that command as part of my container with exec or while I'm running the container. So what I'm doing now, I'm gonna execute or get inside my container, and then I'm going to create this file ephemeral data.txt, and it will have a content saying this data is inside the container layer. Very simple. So let's do that. So I have this command. So what is this doing? Docker exec, we are getting inside the container. We want to do a sh, okay, and then -c is command shorthand. What I want to say, echo, this data is inside the container layer, and that is getting stored into this file called ephemeral data.txt inside the temp directory. Now I've done that. All right. At this point, I want to check if the file was indeed created, right? Because execution has been successful. Let's see. Now what do I do? Because that file is created, I run another exec to my container volatile test, and this time I want to do a cat to give me the contents of this file ephemeral data.txt, and there you go. I see this data is inside the container layer. So right now my container has got some data. It's in running state and it has a data in the form of a file. Now, what do? I will remove this container. Okay, so let me do that. So first I'm gonna stop the container, docker stop volatile hyphen test. So I'm first stopping the container because my container's status is up and running. Because Docker is wanting to stop the container, it's going to take some time. There we go. Now if I do docker ps-a, you see my container has exited now, right? 3 seconds ago. And now I'm going to remove it. Docker rm volatile hyphen test. And now if I do docker ps-a, I don't have any container with me. Now at this point, this file ephemeral data.txt is also gone because this was created inside of the existence of a container, right? So it was part of the container's existence, and hence when the container was gone, the data along with the file is also gone, which in situational cases, which is depending on the justification and the business needs of your application which you are wanting to containerize, may not be convenient or feasible, right? We wanted to persist the data. Now, if you want to do that, like I said, we need something which is having an existence and life cycle outside of the container. And that's where volumes come into picture. So now what we're going to do is we will create a volume, then make it talk to the container, which we will spin up. We will remove the container and we will see the data is still getting persisted because right now it's been set up within the volume ecosystem. All right, so let's get started. First thing first, what we will do is we will create a volume. How do we create a volume? Docker CLI. That's the way how Docker client communicates to Docker daemon, right? And that's how whatever we need created, executed, managed within Docker is taken care of. So I'm going to say docker create volume. And let's give the name to the volume. Okay, it's docker volume create. And we give a name to the volume my underscore db underscore data. All right. So I'm wanting to create a volume called my db data. So at this point, my volume is created. Now, how do I ensure the volume is actually created? I say docker volume ls. Now, at this point, you see there are two volumes available because I had created one earlier as well. So my DB data is now created. Okay. Now, what I want to do, I want to see what's really happening and how this volume is indeed created. What is the metadata behind it? So I say docker volume inspect my DB data. And at this point, it gives me everything about my volume. It was created today, of course. The driver is local. The mount point is where lib docker volumes. And then the name is mydb data. There's no option and the scope is local. So these are, bare minimum important metadata about my volume, which I can check. Now what do I do? Now I want to mount this volume onto a container, correct? And there are two ways how you can do it. You can use the volume argument or the hyphen hyphen volume or hyphen v shorthand, or you can use the mount argument. Both are usable and you use them depending on your requirement. Hyphen hyphen volume gives you a very straightforward set of syntax, limited but straightforward. For instance, it has three fields basically separated by colon, and they have to be in that order. So the ordering is very important. The sequence matter. What do you need? You need docker run, of course. Like I said, we are doing it as the time of container creation come running, and then we use hyphen hyphen volume or hyphen v shorthand. In this example, what you see right here, I'm highlighting, we use the shorthand. You give the name of the volume, which in our case would be mydb data. Then you give the mount path, where in the containers system you want this to be mounted. And then you have certain options which is available to you at your discretion. What are these? These are two options you have: read only or RO. So if you want the volume to be read only, which is a very, very specific case, we will not explore that. Say for instance, you want to mount a volume and you do not want the container to be able to do anything with it. It could be one specific read only data which you want the container to have access to, but not make changes to. You can, in that case, mount a pre-populated data asset to a container. For our purpose today, we are going to do a writable data setup. So we will not give this argument. And then volume no copy, wherein you do not allow copying of your volumes. Typically, again, like I said, depending on your requirement, you use these options. We will not be. The second way of doing it is with the hyphen hyphen mount argument, wherein you specify one, the type, which can be volume. There are different types of volume really. We will explore them in subsequent sessions if need be, because these are the advanced part of it. And right now we are focusing on Docker 101 to get acquainted with the concepts and get clarity through easy demos, right? Then you give the source, which is your volume name. You give the target, which is your mount path. That's it. All right. And then it can be followed by commas, which is your list of key value pairs. Now, again, the order there is not important. This could include read write. This could include the volume subpath, for instance. This is an example. See. So I'm doing hyphen hyphen mount. Type is volume. Source is my volume. The name, destination is the folder or the mount path within the container. And then you give the key value pair of your arguments. It is read only, and the subpath of the volume is slash foo. So this is basically how you can mount your volume onto a container, either using hyphen hyphen volume or using hyphen hyphen mount. For the purpose of today's demo, we will be doing with hyphen hyphen volume. All right. So let's run a container, attach it to our volume. So we will create a named volume, which we did, and then we have to mount it to a container. And let's see this container to have a simple SQLite database so that you see the files are getting persisted. Okay. So now we have created a volume, we know, which is mydb volume or mydb data. Now we have done the inspection also. We have done volume inspect. Next, what we will do, we create a simple container and then you mount this volume. How do I do this? Using this command. Okay. So what have I done? Okay, I have missed the D in my Docker. So let me add that first. And there we go. So I'm doing Docker run to run my container. Hyphen D detached mode, hyphen hyphen name is name of my container, which is DB writer running. Then I use hyphen V shorthand for volume. The name of the volume. All right. So I'm using appdb volume, which is fine. This is a volume also available to me. Appdb volume. The mount path is slash data slash db. And then I give the image, which is Alpine, and make it run with the command tail hyphen f dev null. Okay. So at this point, when I run, my container is started. So when I do docker hyphen ps, docker ps hyphen a, 3 seconds ago, my container DB writer running has been spun up. It is up, right? So container ID has been available. Now it's running in the background. We did the PS. Now my container is running and a volume is mounted to it. At this point, what I'm going to do is I will basically, because my location of this is slash data slash db, right? I will do the same thing. I will echo a content and then put it onto a file in this db folder. And this is the simple exec for it. We have executed this exec again before, but there once the container was gone, my exec executed file, which was ephemeral data.txt, was also gone, right? In this case, let's see if it happens like that. So what am I doing here? I'm doing a simple docker exec on my container DB writer running. I'm doing an sh. I'm giving the command echo database entry 1, and then I'm storing this in a file called database.sqlite, which is in the same mount path, which is mounted by the volume slash data slash db. Okay. At this point, I run this. Something has happened. How do I verify the file exists? We do a cat like we did last time. So I do docker exec, my container name, I do a cat of the file content, and you see database entry 1 is available to me. Now, what I want to do, I want to append some more entries. So we will do database entry 2, database entry 3. So at this point, I'm doing database entry 2. At this point, I'm doing database entry 3. I think that's it. Now, when I do a cat, I have database entry 1, database entry 2, database entry 3. 3 entries are available in my file, database.sqlite. Now comes the interesting part. Let's stop the container. So I'm going to do docker stop. What's the name of my container? DB writer running. So I'm sending instructions to Docker to stop this container DB writer running using docker stop CLI. And it's gonna stop the container, which it did. At this point, if I do docker ps-a, see my container is in exited state. All right, now what do I do? I'm removing this container with docker rm. Container is gone, okay? If I do docker ps-a, the container is gone. Now the interesting thing comes into play. At this point, because database.sqlite is mounted or created on a folder, which is a mount point for my volume, which exists outside of the container lifecycle, even though this container DB writer running is now gone, the data is still there. How do I make sure and see if it is still there? I will spin up another container, a brand new container, and mount the same volume onto it. And then I'll do a read on this container for a data which I created as part of my previous container. All right, so let's get started. So what I'm doing here, I'm running a new container, Docker run. The name this time is DB reader. And then I'm creating it with -rm option. So -rm option, if you give as part of your spinning up a new container, it instructs Docker that whenever this container goes into stop mode, remove it. In our case, what did we do? We first stopped the container and then we explicitly ran docker rm, right? When you provide -rm option as part of spinning up a container, it will automatically remove the container when it gets stopped. Your call. So we are using that argument. Then I'm using -v and then I give the information app.db volume, same location, data db, same Alpine image I'm using. And now I'm gonna attempt to read the data from this same file slash data slash db database.sqlite. And there you go. It's a new container and it has read data which was written by the earlier container which is now gone. So the data is persisted. Why the data is persisted? Because we used volume. Why that happened? Because volumes are maintained outside of the container lifecycle and we use it when we want to persist data as part of our requirements. Make sense? Perfect. Now, we have two volumes with us. Again, let's do docker volume ls. I want to remove it. For instance, I did not use MyDB data. How do I remove it? Same, docker volume rm and then MyDB data. There's a typo. Yeah, so this volume is now gone. Now when I do docker volume ls, I only have one volume available. One thing very important, the volume mount is created within your container. The volumes are taking space in your Docker host, but Docker completely manages it. Okay, so we will not be able to explore how this looks like in my host system. It is completely encapsulated and wrapped and is managed by the Docker. Okay. All right, and there you go. We have completed a very, very simple demo to understand Docker volume. I'm gonna stop the share with that. I hope this was an insightful session. What did we cover? We understood Docker volume. We initially spun up a container, wrote some data, removed the container, data was gone. Then we created a volume, spun up a container, mounted that volume onto the container, wrote the data, removed the container. Data is not gone this time because it's managed by the volume and it is persisted. Then we spun up another container and read the same data which was created by the previous container. So the data was persisted all along because we used Docker volume. That's pretty much it for today. I hope this was an insightful session. Please let me know in the comment section if there's any question, anything you want clarity on, and I'll be so happy to address that. Thank you, everyone. Please take care.